Hey there, and welcome to This Explainer. If you're a Class 10 student, or honestly, just someone diving into chemistry for the very first time, you are in the perfect place. I know that looking at chemical formulas with all those tiny letters and numbers, well, it can feel a bit like looking at an alien language, right? But don't worry. By the time we finish up here, we're going to break chemistry down into super simple step-by-step concepts. We're going to decode the secret language of scientists together, and you'll see that balancing chemical equations is basically just a really fun puzzle. Okay, let's dive into this. Here's our roadmap for today so you know exactly what we'll be decoding together. We'll start with, what is a chemical reaction? Then, we'll decode the state symbols, balance our very first reaction, explore acids, bases, and neutralization, and finally, we'll wrap up with the 5-step balancing trick.
Let's kick things off with Section 1. What is a chemical reaction? Everyday chemistry.
So I want you to think about this question for a second. What actually happens when one substance completely transforms into an entirely new substance? We see things change shape or size all the time, right? Like tearing a piece of paper in half. But what about when a substance fundamentally changes what it actually is? A perfect example of this is literally right in your kitchen. Imagine some standard liquid milk sitting on the counter. Under the right conditions, that milk transforms into curds or yogurt. When that happens, a fundamental chemical change has occurred. The curd has a totally different taste, a completely different texture, and a brand new chemical makeup compared to the milk it came from. You can't just easily turn it back into milk, right? And that is what a chemical reaction is. Chemistry is really just the study of these everyday transformations.
Moving on to Section 2. Decoding the state symbols, the secret language.
Now, what's really interesting about this slide is the brilliantly simple secret code scientists use. They use these 4 little symbols in parentheses to tell us the exact physical condition of a substance. It helps us paint a picture in our minds of what is actually sitting in the beaker. We have an S for solid, like a hard block of ice. We have an L for liquid, like the water you drink. We have a G for gas, like steam rising from a kettle. And finally, we have AQ, which stands for aqueous. Aqueous is just a fancy scientific way of saying a solid has been completely dissolved in water, like salt vanishing into a glass. Whenever we write chemical equations, we tag these little symbols at the end so everyone knows exactly what state the substance is in.
Section 3. Balancing the first reaction. Mixing the beakers. It's time to put our new knowledge to the test.
Picture 2 glass beakers sitting on a lab desk. In beaker A, we have barium chloride. Because we see that little AQ symbol, we know it's a powder that's been dissolved in water. It's an aqueous solution. In beaker B, we have sodium sulphate, which is also an aqueous solution. Right now, they're just sitting there, totally separated.
Now watch what happens when we mix them. We pour beaker A into beaker B. Instantly, a chemical reaction happens. The atoms inside the liquids get super excited and they literally exchange partners. The barium pairs up with the sulfate, giving us barium sulfate, and the sodium pairs up with the chloride, creating sodium chloride. But wait, look closely at this equation. Something is definitely off. If you count the atoms on the left side before the arrow and compare them to the right side after the arrow, they don't match. This equation is currently unbalanced. And remember, we cannot create or destroy matter in chemistry. What goes in absolutely must come out. Let's slow down deliberately here and walk through counting these atoms one by one to see exactly where our problem is. Look at the left side of our reaction. We have 1 barium atom. We have 1 whole sulfate group. But look at the sodium. We have 2 of those. And the chlorine, we have 2 of those as well. Okay, now look at the right side of our equation. The barium sulfate partner exchange is perfectly fine. There's 1 barium and 1 sulfate. But our new sodium chloride pairing, it only has 1 sodium and 1 chlorine. We put 2 sodiums and 2 chlorines into that beaker, but right now, our equation is only showing 1 of each coming out. We are definitely short on the right side.
So the crucial point is, we need to fix this imbalance. We can't change the small numbers at the bottom because that actually changes the substance itself, but we can add large numbers to the front. By simply putting a big 2 right in front of the sodium chloride on the right side, we solve the whole puzzle. That 2 multiplies everything behind it. Now we have 2 sodiums and 2 chlorines on the right side, matching the left side perfectly. The equation is beautifully balanced.
Now look closely at the barium sulfate we just created on the right side of the equation. Notice its state symbol? It has an S for solid next to it. But wait a second, we mixed 2 liquids together. How did we suddenly get a solid? Well, this is literally one of the coolest things in chemistry. Barium sulfate is an insoluble solid, which means it completely refuses to dissolve in water. When this reaction happens, this new solid immediately appears out of nowhere in the liquid. We call this a precipitate. And if you were watching this in a real lab, you'd see a cloudy white powder suddenly form and slowly drift down to settle right at the bottom of the beaker.
Let's move to section 4, acids, bases, and neutralization, the second reaction. We're bringing in some exciting new concepts here.
For our second example, we are bringing together two very different aqueous solutions. On the left, we have sodium hydroxide. This is what scientists call a base. On the right, we have hydrochloric acid, which, exactly as the name suggests, is a strong acid. Think of acids and bases as extreme opposing heavyweights on the chemistry spectrum.
Because they are such extreme opposites, something really beautiful happens when they meet. It's a process called neutralization. When you mix an acid and a base together, they aggressively react, but the end result is that they completely cancel each other's extreme properties out. They neutralize the threat, combining their opposing forces to create something incredibly safe and common. And this brilliantly illustrates that exact neutralization process in action. When our sodium hydroxide base meets our hydrochloric acid, they swap partners. The sodium pairs up with the chlorine to make sodium chloride, which is literally just regular table salt dissolved in water. And the leftover OH group pairs with the leftover hydrogen to make H2O, liquid water, salt and water, two extreme chemicals combined to make something entirely harmless. Let's count the atoms to make sure it's balanced. Left side, 1 sodium, 1 oxygen, 2 hydrogens in total, and 1 chlorine. Right side, 1 sodium, 1 chlorine, 2 hydrogens, 1 oxygen. It matches perfectly. Mother Nature actually balanced this one for us.
Section 5, the 5-step balancing trick, your cheat sheet. Let's summarize this so you have a foolproof trick.
Anytime you face a chemical equation, I want you to walk through this simple 5-step process. First, write down the reactants. That's the stuff on the left side you're mixing together. Second, write down the products. That's the new stuff on the right side that you've created. Third, carefully count the atoms on both sides, just like we did with our table. Fourth, balance the equation by adding those big numbers to the front until both sides match perfectly. And fifth, add your state symbols in parentheses, solid, liquid, gas, or aqueous, so everyone knows exactly what you've made. Reactants, products, count, balance, state. Lock that cheat sheet right into your memory.
Just think back to the two perfectly balanced equations you mastered today. You took barium chloride and sodium sulfate and perfectly balanced the resulting white precipitate. You took a strong base and a strong acid and perfectly mapped out their neutralization into totally harmless salt water. See? Chemistry is not some giant, impossible mountain. It's just a series of small, logical steps. When you take it one step at a time, count your atoms carefully, and follow the rules, it becomes incredibly easy to understand.
I want to leave you with this final encouraging thought as we wrap up our explainer today. Learn slowly, understand deeply, remember forever. You took the time to learn the secret language of state symbols today, and you patiently walked through the atom counting process step by step. By actually taking the time to understand the why behind the mixing of those beakers, you've gained a deep understanding that you are going to remember long after your chemistry exam is over. So, as you look around your kitchen, or your classroom, or just the world outside, I want to leave you with one final question. What other everyday transformations around you are just waiting to be written as a perfectly balanced chemical equation? Keep counting, keep exploring, and keep learning.